Findaway presents.
The most striking difference between the explosion of an atomic bomb and that of an ordinary TNT bomb is, of course, in magnitude. The explosive energy of each of the atomic bombs dropped on Japan was equivalent to about 20,000 tons of TNT. Ordinary TNT bombs range from 1/4 ton to 10 tons. But in addition to its vastly greater power, an atomic explosion has several other very special characteristics. Ordinary explosion is a chemical reaction in which energy is released by the rearrangement of the atoms of the explosive material. In an atomic explosion, the identity of the atoms, not simply their arrangement, is changed. A considerable fraction of the mass of the explosive charge, which may be uranium-235 or plutonium, is transformed into energy. Einstein's equation, E = mc², shows that matter that is transformed into energy may yield a total energy equivalent to the mass multiplied by the square of the velocity of light. The significance of the equation is easily seen when one recalls that the velocity of light is 186,000 miles per second. The energy released when a pound of TNT explodes would, if converted entirely into heat, raise the temperature of 36 pounds of water from freezing temperature, 32 degrees Fahrenheit, to boiling temperature, 212 degrees Fahrenheit. The nuclear fission of a pound of uranium would produce an equal temperature rise in over 200 million pounds of water. The explosive effect of an ordinary material such as TNT is derived from the rapid conversion of solid TNT to gas, which occupies initially the same volume as the solid. It exerts intense pressures on the surrounding air and expands rapidly to a volume many times larger than the initial volume. A wave of high pressure thus rapidly moves outward from the center of the explosion and is the major cause of damage from ordinary high explosives. An atomic bomb also generates a wave of high pressure, which is, in fact, of much higher pressure than that from ordinary explosions. And this wave is again the major cause of damage to buildings and other structures. It differs from the pressure wave of a blockbuster in the size of the area over which high pressures are generated. It also differs in the duration of the pressure pulse at any given point. The pressure from a blockbuster lasts for a few milliseconds only. A millisecond is 1,000th of a second. That from the atomic bomb for nearly a second, and was felt by observers both in Japan and in New Mexico as a very strong wind going by. The next greatest difference between the atomic bomb and the TNT explosion is the fact that the atomic bomb gives off greater amounts of radiation. Most of this radiation is light of some wavelength, ranging from the so-called heat.
Sample complete. Ready to continue?